Math 1, Unit 7, 7.2 to 7.3 review. All right, so this first thing, what is that? What is this question? Who can tell me what that means? Maria?
Isn't it asking you to find the distance between
It's exactly right. Good job. It's the length. When there's nothing above the AC, it means the length of AC. So here we want to find the length from here to here, and it's simply the absolute value of -8 minus 7, which is -15. The absolute value of -15 is 15. The length of BD. Now, if you always take the bigger number and subtract the smaller number, you don't have to use the absolute value. It'll always come out positive. Oops, 11. Okay, so if you remember to do that, always subtract the bigger number, I'm sorry, let me say it correctly. Always subtract the smaller number from the bigger number, or put the bigger number first. You will be better off, or you'll be okay because you won't come up with that negative. Okay, name another name for ray, dA. Well, remember you start with D, so it's anything else down here. So ray dB, dC. Name a ray that is opposite CD. Okay, opposite means it has the same endpoint and goes the other direction, so you would have ray CB or ray CA. Name the line in figure 1 3 different ways. So pretty easy. We could go AB, CD, DA. We got a bunch of different ways, but we got to remember to put that line above it with arrows on both sides. That's the key. Questions on 1 through 5. Okay, let's go on. You guys had a lot of problems with this. So the funny thing is you guys didn't have any problem with this, but you had problems with the next question, which if you followed this, you would have been fine. It says MO plus, and you guys pretty much all knew that it was OP equaled MP. MO plus OP equals MP. Most of you did a pretty good job. We call this segment addition postulate. And then number 6 says if MO equals 3x plus 7 and OP equals 4x plus 1, then and MP equals 10x minus 7, find x, MO, and OP. All right? Well, MO is right here, OP is right here, and MP is right there. So isn't it just 3x plus 7 plus 4x plus 1 equals 10x minus 7? Segment addition postulate. So 3x plus 7 plus 4x plus 1 equals 10x minus 7. And Mr. Montoya, would you do me a favor? I forgot to go around and stamp. Anybody who's done real quick? Thank you. So we combine like terms, and we get, what is that, 7x plus 8 equals 10x minus 7. And, you know, you can do this either way. I like to always have my variable on the left. Doesn't mean you have to do it that way, but I'm going to subtract 10x from both sides, and I get negative 3x. Which means I have to subtract 8 from both sides, which gives me negative 15. Then when I divide both sides by negative 3, I end up with x equals 5. That's the first step. Now I have to find MO. Well, that's simply 3 times 5 plus 7, which means MO equals 15 plus 7, which is 22. And then I need to find OP, which is 4 times 5 plus 1, which means OP equals 21. And in the next question it says, is O the midpoint of MP? Why or why not? The answer would be no, because MO does not equal OP. Pretty simple. Okay, Now number 7 is the next thing we learned. If A is the midpoint of CT, so if they don't give you a drawing, you should always make a drawing. Here's CT, and A is in the middle. So it says if A is the midpoint of CT, so let's show it by putting a couple of congruency lines on there. Now we know A is the midpoint. Okay? If A is the midpoint of CT, then CA, line segment CA, is congruent to line segment AT. Now notice up here I put MO is not equal to OP, because really what I'm saying is the length of OMO is not equal to OP. Down here I'm saying line segment CA is not is congruent to line segment AT. Remember, line segments are congruent, lengths are equal. So then we can simply say, hey, there's AT and there's CA, so let's set those guys equal to each other. So 3x minus 7 equals x plus 15. Subtract x from both sides, we get 2x over here. Add 7 to both sides, we get 22 over there. Divide both sides by 2, we get x equals 11. Okay? Is that what they wanted? Are we done? Part way, we found x, that's what they wanted, but now they want CT. Well, you know, some of you might have plugged in CA equals x plus 15 or 11 plus 15, and AT equals 3 times 11 minus 7. This is, what is that, 26? And this is 33 minus 7, which is 26. Add those together and you get CT, which is CT equals 50. I thought it was 54. Oh well, 52. Okay? So you could do it that way. I'll tell you what I like to do. If I'm looking for CT, well, I know CA is half, so I'll just take CA and I'll double it. That's the way I did it. So that means CT equals 2 times 11 plus 15, which means CT equals 2 times 26. CT equals 52. It's the same way. It's just, I don't know, to me it's a little easier just to take half and double it. Does that make sense? Because we know CA is half of CT, because A is the midpoint. So I just find CA and I double it. Okay, moving on. You're going to have to do both of those on the test, by the way. Both those questions will come up on your test. Number 8, what is another name for plane ABE? Well, let's name it, how about plane ACE? Probably a couple of different options, but ACE will work. Name 2 opposite rays. How about ray BA and ray BC? And we could also do ray BF and ray BD. I think that's our only 2 options. All right. Name 3 collinear points. Well, we've got A, B, and C are all collinear, or we could go D, B, and F are collinear. 2 options there. Number 11, name 4 coplanar points. Well, we'll go with A, B, C, and E. Okay, and by the way, we could name A, D, B, and F. If you could think of a plane, I'll try and draw it here. Think of that plane. Oh, sorry, I got to show it to you. If you can think of this plane right here through A. Okay, there's another plane you could have done if you wanted. D, B, F, and A would have worked. Okay, name the intersection of plane M and plane ABD. Okay, I just drew plane ABD, and this plane M is right here, so hopefully you can see that it's line AB. Line AB is the intersection of those 2 planes. How many got that? How many got that one? That's a tougher one. That's a tougher one. But hopefully you can see here's plane M, the one that was drawn, and then I just drew the plane they're talking about right here. And you can see they're going to intersect right there on that line. Okay. Use the number line below to exercise 12 through 16. Tell whether the segments are congruent or not. So we can say that GH is 4. 1, 2, 3, 4. And HI is also 4, so we can say they are congruent. GH is 4 and IK is 4, so they are congruent. HJ is 2, 4, 6, and IK is 4, so we'll say not congruent. Are you guys understanding my symbols here? Okay. IJ is 2, JK is 2, so they are congruent. That's not a very good congruent sign. 2, 4, 6 for HJ. GI is 2, 4, 6, 8. So we'll say not congruent. And HK 2, 4, 6, 8. And GI 2, 4, 6, 8. So congruent. Okay? All right, how do we do? Mr. Montoya, most of them get it done? Yeah? Okay, good. All right, so now what we're going to do is we're going to go over some angle pairs. All right? Angle pairs, which, boy, I say this every lesson, don't I? We're going to use this, I'll just say this, we're going to use these angle pairs a ton next year. Okay, a ton.